So I wanted to do an example of a density problem, and I wanted to focus specifically on how I deal with units in most of the calculations that I do in Chem 1 and Chem 2. Alright, so we're told that radium has a density of 5.5 grams per milliliter. And we want to know what is the volume of a 14.8 milligram sample of radium. So, of course, the equation for density is that density is equal to mass over volume. And in this case, we're solving for the volume. Now, one thing we have to be careful in all the calculations we do is to be sure that the units match up. And so, in the density for radium that we were given, we're given the units as grams per milliliter. So that means that in order to use this density equation, the mass has to be in grams and the volume has to be in milliliters. And the mass that they gave us is in milligrams. So before I can use this density equation with a density of 5.5 grams per milliliter, I've got to get my units to match up. Now, there are two ways I could go about this. I could either convert the density into milligrams per milliliter, or I could convert the mass from milligrams into grams. I think that second one is a little bit easier because I don't have to worry about those milliliters hanging out. And so that's what I'm going to do. I'm going to convert the mass from milligrams into grams so my units match up. So I know that 1 milligram is 10 to the minus 3 grams. And remember that milli is definitely one of the metric prefixes that I want you to know. And so to do my conversion, I want the units to cancel, so the 1 milligram will go on the bottom, 10 to the minus 3 grams on top, and so I get 0.0148 grams. And so now that I have my mass and my density in the same units, I can go ahead and use the density equation. Now, what I like to do when my equation only involves multiplication and division is I like to solve for the variable I'm looking for first before I put the numbers in. And the reason I like to do that is because then when I plug in my values, in this case the density and the mass, I can include the units with them, and I can see that the units cancel out to give me what I would expect. And so this serves a number of useful purposes. I can confirm that the units that I get make sense, or if I'm not sure what my units should be, by going through this process carefully, I will get the correct units. So in this case, I want to solve for the volume first. So I'm going to take my density equation, and if the thing I'm solving for is in the denominator, the first thing I always want to do is I want to get it out. Right? So in order to get the volume out of the denominator, I've got to multiply both sides by V. So then I have V times D is equal to M. And so now that the volume is no longer in the denominator, I can go ahead and isolate it. And so to do that, I'm going to divide both sides by D. So the volume is the mass divided by the density. Once I've isolated the variable I'm looking for, now I'll go ahead and plug in my values. So the mass is 0.0148. The density is 5.5 grams per milliliter. And then what I usually do is I work the units as sort of a separate problem off to the side. So I have the mass in grams, and then I'm dividing by the density in grams per milliliter. So first, let's evaluate the numerical part. Right, so the volume is going to be 0.0148 divided by 5.5 into two significant figures. I get 0.0027. And now for the units, what I'm going to do here, to make it easier to see how they're going to cancel, remember that dividing is the same thing as multiplying by the reciprocal. So divided by grams per milliliter is just like multiplying by milliliters over grams. And so now I can clearly see that the grams cancel and I'm going to be left with milliliters. And that's comforting. I know that milliliters is a unit of volume, and that's what I'm solving for. I'm solving for the volume, so that helps me give me confidence that I've set up my calculations correctly. So my final units are in milliliters.